Welcome to video 6.1 in our first Principles of Astrophotography series. In this video we discuss the telescope focal length, aperture, and focal ratio.
These concepts are essential in astrophotography, playing key roles in magnification, pixel scale, and optical speeds. I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensor sensibility. Principle 92, focal length. The focal length of a thin lens or mirror is the distance from this element to the point at which parallel rays of light converge.
So these are the parallel rays coming from, say, space or a distant star. And if you're talking about light coming from a star, if you get far enough away from it, all those light rays that are arriving to you are parallel to each other. So then you stick a thin lens. The calculations are easier for thin lenses than they are for thick ones. And those rays then hit the lens, refract, because light travels slower through glass, like we talked about before, than it does through air. That causes light rays to bend when they enter the lens and when they leave the lens, and then all these light rays come and converge at a point, and that point is called the focal point. And then the distance between the lens and that focal point is called the focal length. So that's all there is to it. You can do the experiment if you want. You take a lens, or take your lens from your glasses and shine a flashlight at it.
My contacts.
See where yeah, that'd be tough. See where they come to a focus and measure the distance, and that's the focal length. Simple as that. So what about a mirror? And in this case, we've got a concave mirror. So these light rays come in, all parallel to each other, hit the mirror, and then there's a law that governs the reflections from a smooth surface, and that's that the angle of incidence equals the angle of reflection. And following that law, the rays will then bounce off the mirror and come to a focal point again. And the distance between the mirror and that focal point is called the focal length.
Focal length.
And you might say, well, my telescope doesn't look like that. For example, our Cat 91 has 5 lens elements to it. And you might say, well, how do I measure the distance to the focal point? How do I even measure it? And we'll give a way of doing that I think it's in a later chapter. Really slick way of doing that. Aperture.
Principle 93. The aperture of a telescope is the diameter of its main lens or mirror. This is good stuff. This is how big your telescope is.
Super basic. But the aperture is just the diameter. It's how big that opening is. For example, our Celestron Edge HD 9.25 has an aperture of 9.25 inches, meaning the diameter of that main corrector lens that's on the front of it is 9.25 inches. That's all there is to it. Usually they're measured in millimeters.
But that's how much light it's sucking up. That's
right.
That's where the rubber hits the road.
That's right.
On the aperture.
Which, as we'll talk about in a future video, affects not only how much light you gather, but how good of resolution you can get. The bigger the aperture, the more detail that you can see because of a phenomenon called diffraction, the wave nature, which is related to the wave nature of light.
Detail. That's where we're at.
Yeah. So the bigger the diameter, the more light you're going to capture, and the more detail you'll see. Okay, focal ratio.
94. The focal ratio of a telescope is its focal length divided by its aperture.
So that's a simple equation. We denote the focal ratio by capital F, and it is the focal length denoted by a lowercase f divided by d. So for the C star, for example, has a focal length of about 250 millimeters. And the reason it's called a C star S50 is it has a 50 millimeter aperture. And 250 divided by 50 is 5. So its focal ratio is 5. Sometimes, and different people denote these in different ways, they'll denote the focal ratio as f/5. That means exactly the same thing. It's a focal ratio, f/5. And that goes back to the whole idea of f-stops in cameras. Thanks so much for watching.
And we'll see you next time.